Before starting our lecture, think about this. If our books, notes, or files are all mixed up, can we find what we need quickly? Of course not. First, we need to arrange them properly. This process of arranging things is called sorting. So, today we are going to understand what is sorting, why sorting is important, and the key properties of sorting algorithms in a very simple and easy way. Let's start with the basic question, what is sorting? Sorting means arranging the data in a particular order. This order can be of two types. First, ascending order, which means from small to large. Second, descending order, which means large to small. Let's take a simple example. Unsorted data is 7, 2, 5, 1, 4. After sorting this unsorted data, it becomes 1, 2, 4, 5, and 7. So here the numbers are arranged from the smallest number to the biggest number. Now the next question is, why do we need sorting? Sorting is important because it makes our work faster and easier. First one is the speed up searching. When the data is sorted, searching becomes faster. For example, finding a student's name in a sorted attendance list is much easier than in unsorted list. Second, simplify the data analysis. Sorted data is easier to understand and analyze. For example, we can quickly find the highest marks or the lowest marks when the marks are sorted. Third, improve the readability. Sorted data looks clean and organized. For example, our phone contacts are always sorted by name, so we can easily find any contact. Fourth, optimize other algorithms. This is the important point that many algorithms work only on sorted data. For example, binary search. Binary search works only when the data is sorted. So, sorting improves the performance of other algorithms. Now let's discuss the key properties of sorting algorithms. These are very important from the exam point of view. First is the stability. A sorting algorithm is called stable if it keeps the original order of equal elements. Suppose we have this input A5, B3, C5. After stable sorting, the result is B3, A5, C5. In here, A comes before the C, just like in the original input. So in simple words, stable sorting doesn't disturb the equal values. Now let's talk about in-place sorting. An algorithm is called in-place if it uses very little extra memory. In in-place sorting, we rearrange the elements in the same array, so it is memory efficient. In not in-place sorting, we use extra arrays, so more memory is required. For example, rearranging the books on the same table is in-place sorting. Using another table to rearrange the books is not in-place sorting. Third is the time complexity cases. Time complexity tells us how much time an algorithm takes to run. There are three important cases: best case, average case, worst case. Best case. Best case is the minimum time taken. For example, when data is already sorted. Average case. Average case is the normal condition. For example, when data is partially sorted. Worst case. Worst case is the maximum time taken. For example, when the data is in reverse order. Worst case is the most important for the exam's point of view. Next is the common sorting algorithms. Common sorting algorithms are bubble, sort, selection sort, insertion sort, merge sort, and quick sort. Good sorting makes everything faster and easier. So in today's lecture, we learned what is sorting, why sorting is important, what stability is, what is in-place sorting, and the different time complexity cases. In the next lecture, we will see sorting algorithms in detail. Thank you for watching and keep learning.